Elements are, of course, the building blocks of all substances, and compounds are two or more elements chemically combined. That's the basic gist of it. But they happen to occur that way through the idea of chemical reactions, basically chemical changes. And when it comes to chemical changes, that's, of course, as I said, that's changing one substance into another. But how do you know when something is a physical change or a chemical change? Well, there are, of course, 4 indicators that tell us if a chemical change has happened or not. The first one being transfer of energy. Now, earlier I showed you magnesium burning. Safety first. So, we're going to take this strip of magnesium and burn it to show you that its chemical property is that it burns with a bright white flame. And there you go, look at that. Look at that. Burning with that nice bright white flame. Don't look directly at it if you're doing this. Oh my gosh. Burn it. There we go. And of course, it burned. Gave off a nice bright white flame. That's transfer of energy. It gave off heat. Now, was that a chemical change? Yes. We'll talk about that in a second though. Another indicator is color change. If something changes color, it might be an indicator that chemical change has occurred. So, let's take a look at that burned magnesium, shall we? The magnesium was originally a silvery color, but now you can see it's become a chalky white. That's a color change, okay? The other ones are production of a gas and production of a solid. So what I'm going to show you next are 2 other reactions that show off production of a gas and production of a solid. First things first, we need a little bit of magnesium again. And magnesium, physical property is it's fairly soft. I can just rip it, no problem. And I'm going to fold it up so it's nice and compact. And I am wearing gloves because this one's a little bit dangerous. So I'm going to put my goggles down because safety first as always. And what I'm going to do is in this test tube right here, I'm going to add a bit of hydrochloric acid. That goes in the sink. And then what I'm going to do is I'm going to drop the magnesium in there. And I'm sure you can see it's bubbling and it's giving off steam or smoke or something. That's production of a gas. I put those together, it is producing a gas. And I think I can get this a bit closer to you. Hold on one sec. So there you can see it fizzing. Even the magnesium's like climbing up the tube. But you can hear it fizzing and it's giving off vapor there. So that is production of a gas. Now the other one we're going to do is produce a solid, and I will get nice and up close and show you exactly what happens. So what I've got here in this test tube is salt water. This is just salt dissolved in water. This right here is silver nitrate solution. So there's our test tube of solution. I'm going to pour the silver nitrate in and watch what happens. See how it got nice and cloudy, and it almost looks like it's full of cotton, or like, it's hard to describe, but it got cloudy and it's no longer clear. And this, I can guarantee to you, is clear. So what happened? Produced a solid. And if I let that sit long enough, eventually all that solid's going to sink to the bottom. You can kind of see all right where it's a bit darker here, a bit lighter here. That's because this is sinking down to the bottom. So I'm going to show you one more, okay? And I'm going to take my silver nitrate, pour that in there, and then what I'm going to do is I'm going to drop copper into it. But I want you guys to get up close and see this as it happens. So here's my test tube of silver nitrate, and what I'm going to do is I'm going to drop a piece of copper in there. So here's my my copper wire. I'm going to take that and just plop that in. We're going to sit and wait over time and see what happens.
So you can see here that the reaction has taken place. You can see that the copper wire looks like it grew something, but what's actually happening there is silver is being produced and the copper is going into the liquid, which is why the liquid, you can maybe see it if I put some white paper back here, the liquid turned blue. Okay, so we're producing a solid and we're changing color.
So that showed off our 4 indicators of chemical change. We had transfer of energy, and that was, of course, the magnesium burning, color change, the magnesium burning, and the copper wire in the silver nitrate solution. We had production of a gas, that was, of course, the magnesium in the acid, where it bubbled and fizzed, and production of a solid with our salt and silver nitrate, and, of course, we produced a solid with our copper and silver nitrate. Now, there is one final indicator you have to keep in mind with all of this, and that is it irreversible? Because a physical change can be undone, a chemical change cannot. So think about it. With the magnesium, could I unburn this? The answer is no. Once you burn something, it's done. I can't change it back. And the same goes for color change. I mean, the things that change color, can I change them back? Could I undo this? And the answer is no. The silver has come out of the silver nitrate solution and the copper has gone into the solution. It's completely changed. I can't undo this. Production of a gas, the magnesium in the acid. Could I get the magnesium back out of the acid? And the answer is no. No, it's not going to happen. And lastly, production of a solid. No, I'm not undoing this. There's no way to undo that. So all of those things are chemical because they're irreversible. And that is the key to it. Because just because something produces a solid doesn't necessarily mean it's a chemical change. It's just something you can look at and be like, that produced a solid. That might be a chemical change. But you have to then check, is it irreversible? Because to give you one idea, you could produce a solid by freezing water. But is freezing water a chemical change? And the answer is no. It's a physical change, and it's because it can be undone. Now, last thing we have to talk about is the law of conservation of matter, which states that matter cannot be created or destroyed. That is true in any chemical reaction here, because any chemical reaction, whatever matter you started with, is what you're ending with. Example here, this test tube here where I put the salt water and silver nitrate. Now, I didn't take the masses of them, but if I measured the mass of my salt water, measured the mass of my silver nitrate, and then measured what I got in the end, the mass I started with and the mass I ended with would be the same. Same goes for this test tube here. Now the other ones that produce gases, like the burning of the magnesium and the magnesium in the acid, are a little harder because a lot of that stuff goes in the air. But if I was able to measure all that, it would still be the same mass, because mass of the reactants equals mass of the products. Now everyone, that's the majority of chapter 2 there, so I hope you enjoyed this video. I hope it gave you some insight into some of the things, and you better be ready for your quiz then, because it's going to be on this stuff. Have fun, everyone. I'll catch you later.